Hello everyone, my name is Paul Fisher. I am a physics teacher and I am responding to Black Pen Red Pen's video contest for finding the 1000th digit of the Champernowne constant. David Champernowne was an English mathematician and economist who lived from 1912 to 2000. Champernowne was trying to find an example of a real number that is normal, where no finite sequence within it has digits that occur more frequently than any others, and what is a more perfect example than the counting numbers, or the natural numbers. As you can see here, the Champernowne constant in base 10 is just that list of the natural numbers coming right after a decimal. Now, the reason he included those other famously irrational and transcendental numbers in the last slide is because the Champernowne constant has famously been shown to be transcendental using Roth's theorem. So my goal for this video is to be able to find a MATLAB script to show us what is the nth digit of the Champernowne constant so that we can find the 1000th digit of the Champernowne constant as per Black Pen Red Pen's video contest. Okay, so here we go. We have our Champernowne constant. We are trying to write a MATLAB script that will tell us the nth digit of the Champernowne constant. Okay, so let's start with a simple number. Well, if I want to know any digit less than 10, it is just the digit itself, okay? The fifth digit of this number is 5. So what if I want to look at, let's say, the 19th digit? Okay, well, here's the process I want to use. So I know that these first 9 digits come up to 9, and once I get to the 10th digit, that's when we get into this double-digit series. We're talking about 10, 11, 12, 13, 14, 15 in this part of the number. Okay, so the first thing that I want to figure out is how far into this series is my digit that I'm looking for. So the first thing I want to do is subtract the first 9 numbers off of here, and I end up with 10. Okay, so that means that I am 10 digits into this double-digit series. Okay, so then what do I want to do? Well, I want to figure out now what is the actual number itself, being 10, 11, 12, 13, 14, in which my digit is contained. So how do I do that? Well, I know that I'm dealing with 2-digit numbers. So if I divide the number of digits by 2, I end up with 5. So I know that I am 5 numbers past 9 in this series, which gives me 14. Okay, so I know now that the 19th digit in the Champernowne constant is this 4. Okay, the last digit of this number that I get here. So let's say I wanted to go for the 20th digit. Okay, well 20 minus this first 9 tells me I have 11 digits into the double-digit series. So I have 11 divided by 2 is 5, remainder 1. Okay, so what does that mean? Well, I go 9 plus 5, 14, but I have that remainder 1. So I go 1 more number into it, and I end up with 1 as my 20th digit. Okay, so that's the exact process that we're using. So why don't we try and generalize it in a way that a computer can be able to find the nth digit. Okay, so first thing that I did is see how I said, what are the numbers past 9? Okay, what are the numbers in this double-digit series? So that's the very first thing that we need to figure out is which series are we in? Are we in the single-digit series, double-digit number series, triple-digit number series? Okay, so the way that we can do that is we can look at how many numbers are there in the single-digit series. Well, there are 9. Okay, how many double-digit numbers are there? Well, I see that there are 90, or 99 minus 9, and that means that there are 90 times 2 digits in the double-digit series. Okay, so that leaves me with 180 digits in the double-digit series. Okay, so that means that I already have 189 digits when I start looking into the triple-digit series. Okay, so how can I figure this out? Well, I can see that all that I have to do is take 9 times whatever is my number of digits, we'll call it a, times 10 to the a minus 1. Why is that? Well, we can see when I'm in my double digits, there are 180 two-digit numbers, or 9 times 2 times 10, 180. Okay, so what I need to figure out is for a computer to know that if I take my number, let's say n, and I need to subtract the sum from the one-digit numbers and the number of digits in the two-digit number series. So that would be the sum of 9 times a times 10 to the a minus 1. Okay, so I need to know, when does this term start to get larger than the number of the digit number that I'm looking for? So when is this expression less than 0? Because that is when I know to stop for a. So for example, for the first 9 numbers, I start with a equals 0. Okay, so here we go. I've seen for the two-digit numbers, like when I'm looking for the 20th digit here. Okay, well, I want to just subtract the first 9, so I know that when a is equal to 1, I have the number 20 minus 9, it's still greater than 0. I'm good. When I get to 2 for a, well, then I start to get to a number that is then less than 0, so that means I stop at a equals 1, and I can follow the process from here on out. Okay, so that's how I'm going to get a computer to figure out which series, single, double, triple digit, and so on, we are in to find our number. Okay, so then all I have to do is, once I know which series we are in, I just have to divide this difference by the number of digits in that series, and I just have to add that to the last number at the end of the previous series. Because, as you can see here, once I do that, I find either the digit that I'm looking for, or I have a remainder left that just tells me how many I got to the right. So now let's see how it looks with the actual MATLAB script. Okay, so here we go. So we have the script. The very first thing that I'm doing is just making sure that I'm entering a natural number. In this case, I'm looking for one less than 5 digits because I'm solving for n equals 1,000. So the next thing we have going on here is I'm figuring out what series I'm in. For example, for the 1,000th digit, I will be in the triple digit series. Then I'm doing the same thing. I'm subtracting the number for the last number of the previous series. I'm dividing by the number of digits we are, and I'm looking at the remainder to tell me which digit is the one that I am looking for. And there is an end at the end of the script, but it could not quite fit in this picture. All right, so here is my script. I looked for the 1,000th digit of the Champernowne constant, and it told me it was 3, so now let's check with Wolfram Alpha. And here we go. I have the 1,001st digit on Wolfram Alpha because it counts the first 0 as a digit. So here we go. The 1,000th digit of the Champernowne constant is 3, and I have a MATLAB script that can tell me now the nth digit of the Champernowne constant. Thank you very much for watching.